Hello everyone, my name is Shreya. I currently am a 4th year undergraduate research student at International Institute of Information Technology, Hyderabad. I work with Dr. Aftab Hussain, who heads the Patriot Lab at Center for VLSI and Embedded Systems Technology at IIIT Hyderabad. The topic for my paper presentation is low-cost color sensor for automating analytical chemistry processes. In this study, we have developed a low-cost electronic system to detect the color of a liquid sample in the RGB color space and compared it with a camera-based system. Both the approaches were tested using the experimental setup as shown here that consists of a test chamber to accommodate the liquid sample. The chamber was fed with sample through one of the inlets and the reagent was then injected through another inlet using a syringe piston. In the camera-based approach, an ESP32 cam with OV2640 camera captured the image of the sample in the chamber through the transparent acrylic sheet. The frame size was set to QQVGA and the image format was initially set to JPEG. The values in the camera frame buffer were later converted into RGB format and the average pixel values were then computed to obtain the RGB value for the sample. In the second approach, the color sensor was assembled using an RGB LED and a light-dependent resistor. The resistance of the LDR was measured using a potential divider circuit with a 10 kilo ohm resistor in series with the LDR. The LED was used to illuminate the sample with red, green, and blue lights, and the color information was obtained from the light intensity that is incident onto the LDR after reflecting from the sample. The intensity of each color component was determined relative to a 2-point calibration using white and black color to compensate for any experimental variations. The performances of the camera-based system and LED-LDR system were analyzed by exposing them to various gray shades and is shown in the figure here. Since the LED-LDR system performed better than the camera-based module, we used it to perform some analytical chemistry experiments. The results obtained are shown in the subsequent slides. To perform the colorimetry experiment, we created aqueous solutions of potassium permanganate of various concentrations, each exhibiting a characteristic purple color. Each of these solutions were filled in the chamber to obtain the RGB values, and the average of the pixel values obtained using the system indicate the color intensity of each sample. We then fitted an exponential function to the results obtained to get an equation as shown here that describes how the RGB value varies with the concentration of potassium permanganate. For the titration experiment, a 20 ml 1 molar hydrochloric acid solution was introduced in the chamber and sodium hydroxide was added to it in steps of 1 ml with phenolphthalein as the indicator. We noted the RGB values at each step. A sudden change in RGB values was observed after adding 20 ml of sodium hydroxide, indicating that equivalence point has been reached. It is observed that this versatile low-cost color detection system gave accurate results and could thus be employed for use in various industries on a large scale to completely automate the chemical and biomedical processes. Thank you.